So when we're talking about systems of equations, we still have all the different methods of elimination, substitutions, linear combinations. Forgot the third one for a second there. And what happens here is that you want to use one equation and eliminate a variable in two others. And then you just start piecemealing it together. Have any of you guys done a 3x3 before? Okay. So if you look at here, what we want to do is you want to make, this is where your first decision is kind of important. You want to figure out what variable is the easiest to eliminate in two of them. I wouldn't worry about multiplying it by 2 because see how I've got one positive z and the other two are negatives? So what I'm going to do is I'm going to use that positive z as, you'll hear me use the word pivot, as like a pivot to eliminate z in both of the other two equations. By doing that, we'll be able to get two variables and things like that. And we can do that for two equations. So here's what it looks like. Did you guys get that down? Because I'm going to shrink so I have a little bit more room. Here's what it'll look like. What I would do is I would take my 2x minus y plus z is 4, and then I have x plus 3y minus z is 11. And I'm going to redo it again here. 2x minus y plus z is 4, and I have 4x plus y minus z is 14. In both of those equations, if I add them together, what happens to the z's? They're gone. That's what you're trying to do. You're going to use one equation to eliminate a variable in two. If we add these guys together, remember when we split them out, 2x and x is 3x, negative y and 3y is 2y, z's are gone, and then this equals 15. Then I do that again. 6x, negative y plus y is gone, isn't it? That's okay. That's actually kind of a nice thing that happens. Z's are gone, and what's 4 plus 14? 18. Which means now, what can I do for x? Yeah, so what's x? 3. I know then right away that I have value of x is 3. Where do you think I'm going to put that value of x now? In the second equation. And then just go back and substitute through. Sometimes this works out real quick like this. Sometimes you'll get 6x plus 2y is 12. And then you have a system of equations that you'd have to eliminate. You might have to do it a couple times. X is 3. If I substitute back in here, I get 3 times 3 plus 2y is 15. 9, bring that over, it gets me what? 2y is 6, I believe. Y is, well, look at that, also 3. Will your answer always be 3? No. And then lastly, what do you think we do to find z? Yep, exactly. You just go back. Does it matter which of the 3 equations you use to figure out what z is? No. I'll just use the top one. 2x minus y plus z is 4. So 2x minus y plus z is 4. So that means it's 2 times 3 minus 3 plus z. 6 minus 3 is? 3 plus what is 4? 1. There you go. Now, this is what's going to be a little bit different. In the past, when we found our systems of equations, you're basically figuring out where 2 lines were intersecting, and you would figure out that was an ordered pair, it was a point. Well, this is 3-dimensional, where 3 planes are intersecting. You have, bless you, so it's an ordered triple, is what it is. Okay. So it goes in order: x, y, and z. It's an ordered triple. Or in textbooks or things like that, they'll use R, S, and T, A, B, and C. They'll use letters like that. Well, yeah, you use letters. Just put them alphabetically. Okay, well, that's what it looks like. Yes, sir.
I'm guessing that would be graphing.
Yes, sir. Yep. We don't actually graph anymore in 3 dimensions. It's a little bit weird. It's every textbook that I've seen does it a little bit differently. X, It's really hard to visualize it through. You have, it flips your axes, it goes X, Y, and Z. So X and Y are like the plane out here, so this is X, what was it, 3, 3, and 1? So you'd come out to here, but then you'd float it to here to make it look like it's that. It's weird. Yeah, so don't worry about it. Your brain is like, no. Yeah, we're not going to graph these. Don't worry about it at all. Yay! No. Nope. No, not in, there isn't, I know we don't do that, and we don't graph 3 dimensions at all in this class. Everything we graph will all be 2-dimensional. Pre-calc, when I taught pre-calc a few years ago, we never graphed anything in 3 dimensions. Basically, 3-dimensional land is just solving equations for us. Even in college, I don't remember graphing 3 dimensions, to be honest with you. I really don't. I know that we had to solve a bunch of things like this, and there was other ways of doing some stuff, but it wasn't anything out of the ordinary, if that makes sense. So it's kind of like, yeah. I don't, but I have a marker. Anybody else have a pencil? Yeah, I don't have, well, you're the best. Ooh, it's chilly. It's like the cold drawn. That's a joke. Anyway, on this one, I started to put one together. These are the types of problems with so many letters and numbers and things that they're all stacked together that if you start to get god awful results, you probably wrote something down incorrectly. It is so common to flip-flop a number or put it in the wrong line. It's not the end of the world. So if you wind up getting something that isn't like a regular half-Z or quarter and stuff like that, or 3/4 and stuff, or if you're getting some god-awful numbers, it's not me being a jerk. It's probably something that either some math went really, really bad, or a number got flip-flopped. Okay. So in this case, what do you think, or what do you see that might be the easiest one to use to help eliminate things in others? Use the middle one to eliminate y's? Okay, that's kind of what I would do, because I see right off the bat, I know that I have an alternating sign between the top 2 equations, but here I can just wind up doing some subtraction and just rewrite stuff through. It's not terrible, but anytime I can add stuff, it's always easier on the brain. So, excuse me. If I go, let's see, 2x, I'd have to double it. Double the 2x minus y plus 3z is 4. I'm using the doubling of that right off the bat because I know if I add it to the first equation, I have to have that y value with a factor of 2. Okay. So I write it out. I get a 4x minus 2y plus 6z is 8. Then I'll write the second equation below it, or sorry, the first equation below it. 3x plus 2y plus 4z is 11. It's a lot, I know. Slide this up a bit here. And then obviously to eliminate them, we add them together. Okay. We add those together, what, 7x, 10z, 19. Okay. And now to the second, or to that 2x minus y, to eliminate the third equation, I'm going to multiply it by 3 this time. Are you guys okay with doing that? See what I'm doing? You just went cross-eyed on me. What happened? Yes, sir. That's what I'm doing. I'm just going to multiply. I'm going to multiply this one by 3 because then I'll subtract the 2. And then because you're right, because you get the same coefficient, same sign, you would subtract. So if I go 3 times that, it's 2x. So I'll get 6x minus 3y plus 9z is 12. Great reminder on how we distribute going across everything in parentheses. And 5x y. Subtraction. When you're subtracting these things out, this is kind of where people make mistakes. Yeah. If you use the method like I do by putting those vertical lines in there to separate each portion of it, make sure that you always do that prior to any of the signs. That way you know if something's positive or negative. I use it as just a visual thing of knowing what I'm subtracting together. It's just a way of grouping it for me. If it works for you, great. If you use something different, I'm not to say there's one method better than another. And I'm just going to say I got to subtract all these. 6 minus 5, 0. We got that. Not too terrible? Yes, ma'am. It's called scaffolding. We start with something that looks really easy, then I kind of go, well, then you got to do this extra step. Which means, well, we got to do this extra step. Now you have these two equations. And what would you do? Yep. I would multiply the bottom one by 7. You wouldn't do that? You would use substitution? Okay. You can go either method, it doesn't matter. If you multiply the bottom one by 7, then you'd have to subtract the 2. Subtract the 2. It would be fine. If you use substitution, all you have to do is just move that 4z over. That works just as well. Okay? Which one do you want to do? Okay? So then I know that x is 13 minus 4z. So let's see here. We get 7 times the quantity of 13 minus 4z plus 10z is 19. 91? Bless you. Is that right? 91? Uh, 18. Subtract the 19 over 6. Was that? 62? Does that sound right? $72. Sorry, I just realized I did that wrong. I took too many off the other side. The sun fried a couple of my brain cells of subtraction. Divide that out then, and what do we get? 4? Yeah. So now you know your z value is 4. If you know your z value is 4, start putting it in like it's called an ordered triple. Since you've already identified what x has to be, I would substitute there. 13 minus 16. Negative 3, very good. So x is negative 3. And then way back up top. Bless you. I'm using, bless you. Negative 6 plus 12, 6. Minus 2. Does that sound right? So like you were saying, what happens when it doesn't work out quickly? It wasn't terrible. It was just basically just adding an extra step. So not too terrible, is it? Could we do this with 4s and 5s? You're right. It would be awful. It would be awful. So before I do that, I want you to think of this. When you're solving equations, when you solve an equation, what in fact are you using? What are you doing? Yes, sir. What are you using to solve that equation? Division? You're using division, correct? But what is division in relationship to multiplication? The opposite. In math, what do you call opposites? Someone said it. Inverse. Inverse. And I see where you're going with reciprocal. Now, an inverse operation is how you undo something. You okay with that? Now, on your calculator, let me see if I can get this turned on here real quick. There is a little button that you may or may not have noticed before. No thanks. No thank you. There's a button on there that helps you work with what's called an inverse. You guys ever see this one? The x to the negative 1 power? That stands for inverse. If you do 3 to the inverse and hit enter, what do you think is going to happen? What is it doing? It makes a reciprocal. Anything to the negative 1 power is a reciprocal. Right? How you would undo multiplying. So if you had this equation, if I did 3 to the negative 1, that means I'm multiplying it by 1/3 times 3. And if I do that to one side, I have to multiply it to the other side. That's how you would undo it, using an inverse operation. Okay. So what's 1/3 of 6? 2. Okay. Now, this also works with basically all other math stuff that you go through. As you're working backwards to solve equations, you've always been using reciprocal properties. To undo addition, you subtract. To undo square roots, you would square. To when you guys found angles last year for trig, remember in right triangles, you had to use inverse sine. That was sine to the negative 1. It was the inverse property. It means what angle has the sine value of blah, blah, blah. That's where all this comes from. It works as well with, I hate the back button on this. We go back into this. You can kind of do the same idea here. Now, have you guys, I don't want to, there. Have you guys ever seen that symbol? What is it? The brackets, okay. Have you ever seen that symbol when you put numbers in it? Sudoku, yeah. Have you ever seen anything like that? What is it? It's called a matrix. You guys ever heard of that? Matrix. You tried, right? A matrix in this case here, what I did is I did what's called a coefficient matrix. I took all the numbers in front of the variables, including their signs, positive or negative. if by chance I was missing one, let's say it was just 2x plus 3y, or 2x plus 3z, what do you think I would put for a placeholder for the y value? 0. Okay. You put zeros in there to do that. So what I've done here is I've created what's called a 3 by 3 matrix. 3 rows, 3 columns. Okay. Row your vote, remember you go left and right. Otherwise, if you wrote a vote up and down, you'd be dead. This is one of a waterfall. Okay. This has to equal, if I multiply it by something, I'm going to do this first. By something, it has to equal 11, 4, negative 1. Now here's the thing. How do you undo multiplying something? Division. Division is the inverse operation of multiplication. So in order for me to take these coefficients and, for lack of better terms, inverse them, I'm going to get my answer will equal, if I learn how to multiply this out. But that means you have to learn how to get it determined. See the sheet on the brown paper on the back wall there? That was a 5 by 5 equation that we did once, and I said, hey, why don't you hand crank out the determinant? I think I had one kid that actually tried it. I think the answer was wrong. But anyway, it just looked really awful because it takes forever to do that. But wait, there's a calculator. There's a button. So what I want to do is I'm going to go to my screen here, and I believe it's under Alpha Window. No, it's... Oops. Alpha Window. Excuse me, Alpha Zoom. Alpha Zoom is a shortcut, and it's talking about rows and columns. So the first thing I'm going to do is I have to put in my solution column matrix. What was it? 4, 11, negative 1, I think. So it was 3 rows, 1 column. And what's nice is that if you screw any of this up, oops, it's going to show you a visual of what it should look like. 3, 1, and then go down and hit OK. Okay, put in the numbers. It was 4, 11, negative 1. Okay, 4, 11, negative 1. You have to use the negative button, not the subtraction button. Okay. Oh, you know what? I think I just backwards this. Yeah, and then we have to obviously do a 3 by 3. Thank you. It has to be backwards, doesn't it? The 3 by 3 has to go first because 3 by 3 row 3. Yeah, okay. I just caught my mistake here. When you do this in the calculator, the 3 by 3 goes first. Okay. Inverse of the 3 by 3, then you multiply it by the column. Just put these in. I just realized the 3 by 3 has to go first. There's rules when you're multiplying stuff together. I just realized that. So I'm going to delete this, and I'm going to create a 3 by 3 to start. It is so much easier to do this on a handheld. Can I see your sheet, please? Thank you. So let's see, we have 3, 2, 4, 2, -1, 3, 5, -3, 5, inverse. Okay. Now do your column. (11, 4, -1). What did that just solve? What you just did. X, Y, and Z. Yes, ma'am. What happens here, guys, it just takes time to put it in the calculator. Bless you. One of the reasons why we don't spend so much time working in upper larger styled equations, 4x4s, 5x5s. There's a button on your calculator with your okay. It's understanding how those buttons work and how they relate to be able to do your stuff for you. For those of you guys that are taking SAT or ACT, obviously there's a practice test coming up. 9 times out of 10, you're going to see some form of system of equation. Well, when you get systems of equations that are 2x2, and you have multiple choice, are you ever going to solve them, or are you just going to substitute and plug and chug? Seriously, never do it by hand, ever. Press buttons in the calculator, substitute, and see what you get. If by chance, as you get going on these things, and you start to see that, please stop doing it with my one lines. Thank you. As you start to see doing these things with calculator work here, if you see a 3x3, if you have 4 variables, 4 equations, coefficient matrix, inverse, solution column matrix, hit enter. It goes in order of the variables, x, y, z. There's a lot of math going on in why this happens, but obviously there's no reason for us to crank any of these things out by hand anymore. That's why in most textbooks, we skip the chapter on matrices. It's something you don't need to do unless you're going to be a math major. So if you're going to be a math major, we'll talk. If you're not, there's a but. Yes, ma'am. What do you think my answer is? I'm going to ask that you do one of these by hand today, and everything else is calculated. That's it. And if we would one with the calculator, wouldn't you check it anyway? Algebra's good. It's good for your brain. But is it a pure necessity when you have technology to take care of? There's a time and a place. This is a time and a place that we don't need to really crank them out. Sure. I normally, and that's the thing, once I start showing you guys certain things in the calculator, I normally don't assess it because you should be able to use the calculator. Now, it's not to say that there isn't going to be a time and a place where you have calculator, non-calculator. For example, when we get going into the quadratic stuff, the first few of those will probably be non-graphic. I won't let you use the graphic calculator. I'll let you use a dummy calculator for multiplying and stuff like that. Yes, ma'am. I don't have one. That's why we're just practicing with it today. As you get going, if we start using it more, it's really quick to find them. Like the matrices ones are alpha zoom. The other ones were alpha window. The main shortcuts are either Alpha Window or Alpha Zoom, and you just look through those, and then you get going through it. As we get into using the calculator for other stuff, maybe I think towards the end of next week, I'm going to do a lot of calculator work with you guys again, and it's how we set up and work with our windows and how things work as far as the parabolas are concerned for word problems, because you need to use the calculator to do a lot of those. And I'll focus solely teaching with the calculator probably the end of next week. But for right now, if you remember Alpha Zoom, you'll be fine. Okay? Yeah. Let's see. Yeah. Let me see my text here real quick. I forgot which. So let's do this. Do one of them by hand. I don't care which one, but do one by hand. The other four, you just put them in the calculator. Textbook here, if you want to take a picture of them, knock yourselves out. Otherwise, I believe the PDF file is already posted. Yes, sir. Yeah. Where is it? I use Classroom to send you to my website. All right. I will remind you as you go through.